Hello, I'm Stefan Graeber. I'm the project leader for LXD, and today I'd like to go over snapshots. LXD supports snapshots kind of the way most people will expect them. It's possible to snapshot the disk of a container of a virtual machine, and then list those, delete them, or restore them. You can also create instances from a snapshot. To easily see what was in a particular snapshot without having to actually revert that the origin of the snapshot. But LXD also supports stateful snapshots and stateful stop, which are two very special features that are probably doable with a number of other technologies, but maybe not as nicely integrated as they are in LXD. So I'd like to go over our snapshot story and especially what we do around stateful snapshots. Mostly regarding virtual machines on that front. So let's get started. And I just took a system that I need to install, refresh LXD on real quick. I'm gonna be using the latest release. So I'm gonna be using LXD 420. And then just need to do a basic configuration on it. I'm gonna configure it so that the instances are directly connected to my physical network. It's gonna make it easier to demo. So I'm just gonna be using, not using a new bridge, but using an existing bridge. In this case, I've got one called BR0, so I'll just be using that. Okay. Now let's start with maybe just looking at containers and the basics of snapshots. So let's take 2004, create a container called C1. And we have that container running now. And I can, well, let's first go inside that container. So go inside it, touch a file called blah. Blah is there. Create a snapshot on C1. Let's call that first. Then if I go in there and I touch a new file called foo, then we'll have both blah and foo. And if I restore that snapshot, it was called first, and go back in the instance, then foo is gone. We reverted over to blah. Now, similarly, I could say create foo again in here. So we've got both of them. And then I can copy that first snapshot. So C1/first and call that C2, which now created a second container called C2. I start that container and go look at what's in the root directory. Only blah is there because it was created from the snapshot. So that's really the basics for snapshots for containers. Additionally, you can not specify a snapshot name, and LXD will pick one for you. So it shows here as snap0. Snapshots can be modified to have an expiry. It's also possible directly at creation time to change some of the settings. You can use the reuse flag to say that you want to replace an existing snapshot with a new one. LXD expiry can be configured globally configured on the instance with a config. So you do to and snapshots.expiry and say it expire after 2 days. Oops, not U2, it's called C2. There we go. And so if I make a new snapshot now on C2 and go look at it, you can see it's got an expiry. And you can force a new snapshot to not have an expiry with no expire. Okay. To which point it doesn't. Snapshots can be modified. We've configured it. So you can do C2 snap 1, and then we could go here and like change the expiry to be a year later. Save that, and that got changed. So again, that's kind of the basics for snapshots on containers. They work just fine. You can restore that stops the container, restore the file system, starts the container back up. Snapshots can have expiries that can be configured on the instance. You can also change the snapshot pattern to anything you want, so that you can set that if no name is provided, a specific pattern is applied. And it's also possible to apply a schedule on the snapshots. I can show that real quick. So if I do config set on C2 and I do snapshots.schedule and I do change remember at startup, I think. And then if I restart C2, what we should see is a new snapshot showing up. Yeah, and the way it's configured right now, every time the container will start, it will make a new snapshot. Alternatively, you could do like at daily or a cron pattern, and then snapshots will be automatically created. And if they've got an expiry, they will also get automatically deleted as they expire. So that's kind of the fundamental of snapshots in Next.de. Where things get interesting is, especially with virtual machines and some of the additional flags we support on some of those snapshots. So let's create a VM. So let's create v1. And first we'll just try some of the basics of snapshots again, just taking a snapshot, creating a VMs from the snapshot. With VMs, LXD treats it the exact same way, but you do need to keep in mind that it's snapshotting a block device. And so if a write is not fully flushed, the snapshot might be slightly inconsistent. It's also possible that you'll get like a disk check forced when restoring a snapshot effectively if the virtual machine was not stopped at the time it was snapshotted. I think that's all pretty normal for virtual machines. So I'm just gonna give that. I can watch it boot. Okay, so it's doing its initial reboot. Booting up now. Okay, so it should be responsive already. Let's just reset the terminal and go in v1. Okay, so here I'm gonna just create a file called blah. I'm gonna sync the file system to make sure it's properly flushed. I'll make a snapshot of v1. And let's copy, it's gonna be called snap0 out of the box. Let's just copy that into a new virtual machine and start v2. And see if we've got the file there. It should be there because I touched it and then I forced a sync of all cache data onto disk before creating a snapshot and then creating a VM from that snapshot. So there's a very good chance that got flushed properly. Let's see if v2 is running already. Not quite yet. Shouldn't be very far away. There we go. And the file is there. So that's again the kind of the basics, works the same way, containers and virtual machines. And the same snapshot patterns and expiry and everything works equally on both. Now let's stop, I guess we can mess with v2. So let's stop v2 and set a config key on it called migration.stateful. For those who watched the announcement of LXD 420, I had to set that key for live migration. It's also going to be needed here for stateful stop and stateful snapshot. So I need to set that to true. And then I need to override the root device on that particular VM so that we also give it some state, some space for storing its state. That VM is 1 gig of RAM, so I think 1 gig had to be enough for the state. Okay, and now I can start the VM. So I'm just gonna let it boot. And once it's booted, I'm gonna be pinging it from my desktop. Just need the IPv6. Come on. Takes a little bit longer to show up. Well, I guess I could ping the IPv4 too, that'd be fine. Fine, let's do that. So I'm gonna be pinging the IP address for that VM from my laptop. And now what I'll be doing is, let's do a stateful stop. So stop v2 -- stateful. And we can see it's still responding while that's going on. So as far, like for a few seconds, the guest was still running perfectly normally. while its memory is being dumped. And at the last moment, it actually gets frozen, the rest of the memory is dumped, and stop completes. So now the VM is stopped. But if I start V2 again, it takes a bit longer than your normal startup, but then it pings immediately. And that's because it was just restored directly from its state on disk. So we can see it is started back up. It's not super obvious what happened because the uptime is still, it was at 0 minute at the time it was stopped, so it's not the most visible thing. But we can just wait. Okay, now it's at 1 minute. And where that gets interesting, so effectively the VM was stopped, everything was saved onto disk, there was no more, I can do it again, there were no more processes running or anything about it. So if I stop it again, and then look at the processes that are running, you can see C2 is running here, C1 is running here, but that's it. And V1 is running down here. V2 is not running on this system. And it's currently not pinging. And then if we start it back up, it immediately starts pinging. If we go back inside it, uptime is still 1 minute exactly as it was. So that's pretty neat. It lets you, not have to boot everything back up, start everything back up inside of a guest. You can just effectively freeze it wherever it was and start it back up when it's convenient. The other thing that's interesting is because you can do something like this. You can do stop, stateful, and while that's done, you reboot your system. So that can be useful if you need to apply a kernel update or apply any other kind of update. You need to go to your BIOS or anything, and you don't want to then have to start all of your VMs back up, get everything running and again in them, and make everything back up. It lets you just save the state of the VM, reboot your system, and then start it back up. So I'm just waiting for that machine, for the server to be done rebooting. And then once it is, I'll get back into it with SSH and then just start the VM right back where it was. That's particularly useful if you're doing any kind of maintenance on servers, or especially are dealing with workloads that you don't run yourself. Like it might be VMs for someone else. It might be some kind of internal private cloud type thing. And this feature lets you pretty easily carry on maintenance with limited impact on the workload. It depends on how quickly your system reboots, obviously. Like in this case, I don't know, took a minute or so. And then how long it takes to actually start the VM backup afterwards. But it can be quite a time saver, and it will work just fine even if you can't use live migration, even if you don't have another system to move those instances to. So in this case, we can see it's responding again, and if I exec into it, we're exactly where we were. So it was about 2 minutes at the time it was dumped. We're back at 2 minutes again. Now, one thing that's kind of interesting, and that one I'll just let run in the background for a bit so that it's easier to show what's going on, but I could do a normal snapshot for V2 like that, and that will get me a snapshot here called snap0, but you'll see there's a column called stateful, and it says no. Now, if I run the same command with --stateful, we'll see that snapshot takes significantly longer to be made because it needs to dump the memory. But now we've got that second snapshot here called snap1, which is marked as stateful. So that's interesting. Now, for the easiest test for that is go in the VM and, I don't know, remove blah. I mean, for that matter, remove all of itsy, break this thing properly. Now, I could restore a normal snapshot and then reboot the VM. But if I were to do that, my uptime would go down to 0 because it would be rebooted. Now, instead, what I could do is do restore v2 snap1, and then go straight back into the VM. Was I supposed to do dash stateful? I've not used the stateful snapshot too much lately. I think you need to do that. Okay. All right, so let's see. Yeah, there we go. So if you just do restore, it restores just the state, just the storage state as usual. But if you do dash stateful, then it does restore the state as well. We can see blah is back, Snapshots is back, uptime is back to 2 minutes. Where it gets kind of funny is that you can now technically do something like stopping v2, starting it back up, giving it a few seconds to start. Probably not ready yet. No, it's ready. And we can see it's got an uptime of 0 minutes. Let's ping it for good measure. And then restore the stateful snapshot. So it's no longer pinging. Now it's pinging again. And if we go back inside it, now it's got an uptime of 2 minutes because it just went to its saved state. And that lets you actually save as many past state as you want for your VM. And you can just go back to it. One last example I've got of this before we wrap up is with something more complex, and let's see if that works. So here I'm on my desktop and I've got a VM which is called Win11, which is currently running. So I'll just stop that quickly. Not stopping quite as quickly as I would have expected. Okay, anyway, it's gone. Then Win11, it has a stateful snapshot as well called snap0. So let's do that here. So restore Win11, snap0 stateful, and then tell it that as soon as that's done, get me a console on it. So Win11, and I want a VGA console because it's Windows. There's nothing interesting on the CLI, on the text console. This one will take a bit longer, simply because there's more stuff in memory to deal with, because it's an entire desktop, and the snapshots are compressed. So the memory state is compressed, but there's only so much we can do with compressing memory. So in this case, I think it's probably dealing with restoring like 2 or 3 gigs of memory. So it takes a bit longer to actually restore it, but the thing that's interesting, and it just did it now, and it's back. And as you can see, it didn't boot, it didn't log in screen or anything. It went straight back to where it was, directly restoring that snapshot. Yeah, so it can take a significant amount of time to save that state. Like a stateful snapshot can take a lot of time to happen. The good thing is it doesn't impact the workload. Like it doesn't really freeze the VM up until kind of towards the end of it. So the actual downtime that's needed to take a stateful snapshot is quite minimal. Restoring it can take a while, like we saw here. Like it was restoring 2 or 3 gigs of RAM from disk, and yeah, it takes a little while to read it, decompress it, put it back into place. So the restore might take a little while, but the snapshots themselves or the stateful stuff itself doesn't take very long. And I think that kind of seamless integration is somewhat unique to LXD. It can be really interesting. We've been using those kind of tools when dealing with things like bugs, especially, where you might have an idea of a reproducer to get to a specific bug, and once the bug is hit, the VM is completely broken. Well, with this, you can do a stateful snapshot right before you're gonna hit the bug. And then you get to hit the bug over and over again, changing debugging, changing things by just restoring to the snapshot and just doing the next step again and again and again, and not having to go through the entire setup steps that you might have ahead of time. So that's really a massive time saver in those kind of cases. On top of the use of doing a stateful stop prior to like doing server maintenance by just, instead of doing a clean shutdown of everything, just saving their state, restarting, and then restoring the state. And all of that feature, especially around virtual machines, is exactly what the live migration feature we rolled out in 420 is based on. We effectively rely on that same logic to, in that case, save the state and transfer everything to a remote server and then restore it there. And that's effectively the basics of our live migration story. So I hope this was useful. I think it's not a feature that's super, well, that's really known about all that much. But it's quite an interesting one, and it definitely has its use cases. And I'm hoping that is something that will be useful to some of you. Thanks for watching. See you in the next one. If you've got any questions, you can ask them below in the comment section or on our community forum. Thanks.